Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering. In this session, we are going to study the basics of vibration. So, what is the vibration? Vibrations are nothing but oscillations of a system about an equilibrium position is known as vibrations. The another name of vibrations are also known as oscillations. Okay. Now here there is a equilibrium position in this position versus a time graph. You can understand here. Here the vibrations are generated by a system such as a spring mass system and also pendulum system, simple pendulum, to understand the concepts of vibrations. Next, the vibrations are we can see in everyday in our life, such as while traveling in trains and also while traveling in aeroplanes, we can feel the vibrations. Not only that, feeling the vibrations in aeroplanes due to aerodynamic forces, these vibrations causes the wings under vibration. When we are inside the plane, we also feel the vibrations. And when we are traveling in two-wheelers or cars, we can feel the vibrations when it is moving on the roads. So not only here, the vibrations are under the on traveling, and also we can feel the vibrations when our heart is beating. Those also we can feel the vibrations. So some of the vibrations, harmful effect of vibrations and useful effect of vibration, there are two categories. The harmful effect of vibrations when the table fan is under noisy. So under noise it causes harmful effect. And also distraction purpose, it is also harmful vibrations. So one more thing, harmful vibrations here under when it is the bearings, general bearings under wearing, so it causes vibrations which are very harmful. And also due to continuous rotation, there is a wearing, it causes the fatigue. This fatigue also causes vibrations. These are the various harmful effects of examples for harmful effects of vibrations. And what is the useful effect of vibration? The useful effect of vibrations are such as for the hand drill or compressor, which is useful for effective vibrations. And the testing, the vibration shakers are useful for testing purposes. Those are also useful effective vibrations. One more, ultrasonic cleaning, also useful effective vibrations. So here, this noise takes place because of the wearing of the bearing inside the table fan or ceiling fan, causes the tremendous noise. That causes the harmful for our human body, humans. And also here some of the destruction purpose useful. So under if we give the vibration as the basic foundation, the whole structure will be demolished. Okay, next, day-to-day life in our vibrations, such as our heartbeats. So here our heartbeat and our lungs oscillations, and we hear because of the eardrums vibrations, and vibrations makes us the snoring. And also here one more thing is that light waves permit us to see, and the sound waves allow us to hear, and we move because of the oscillation of the legs, and we move our hands because of the oscillations of our hands, and we cannot utter vibration without the oscillation of larynges and vocal cords. The moment we are speaking, that is also vibrations by larynges and vocal cords. So here these are all daily way of vibrations. So the vibrations, when we'll see that there are various types of vibrations in our day-to-day life. Vibrations here actually not only for mechanical vibrations, and also dynamic systems of a structure also causes vibrations. So here the main the structure, the whole vibrations are going to be studied mathematically, considering as a mass and spring mass system. So now here the mass is having mass and elasticity element. What here the whole system is under a mass, it is vibrating due to a elastic element, that is what is spring. That's why here it is spring mass system. So the spring mass system is quantified by using a stiffness or spring constant. So how to find out the displacement x? Okay, what is the displacement x? The x equation can be calculated. For this, here the equation of motion by using Newton's second law of motion, the completed the equation, the system, spring mass system is, we are going to draw a free body diagram such as the mass and it is in this direction, acceleration, that is x double dot, m into a, that is m into a downwards, m into x double dot, that is m into d square x by dt square, that is in terms of, that is kx. So m into x double dot plus kx equal to 0, or m into x double dot positive, that equal to minus kx. So here the m into x double dot plus kx equal to 0, x double dot plus k by m into x equal to 0. So x double dot equal to minus k by m times x. So according to concepts of simple harmonic motion, acceleration a equal to minus omega square times x. So if we compare both the equations, then by comparing that, omega square equal to k by m. What about omega? Omega equal to under square root of k by m. This omega is nothing but a circular frequency. So this is omega n by 1 by 2 pi under square root of the frequency fn f equal to omega by 2 pi. Okay, radians converted into revolutions. That revolutions, one revolution equal to 2 pi radians. So we are converting the revolutions into radians. That is finally that cycles per second, 1 cycles per second. That is 1 by 2 pi times under square root of k by m. That is the frequency. Now, the point is that these are the explanations of equations of motion. Further, we'll explain in detail what is the displacement equation, what is that equation x equal to. Now, here what we are going to do, the oscillation systems, especially when the machines are under rotating condition or under operative working condition, generates vibrations. Those vibrations are equal to the natural vibrations of the system. It causes the amplitude of the vibration will be increased. That phenomenon is known as the resonance phenomenon. Okay, we'll see further more and more. We will get what is, by understanding all these things, useful, harmful vibrations and useful vibrations. Is this vibrations are friend or foe? Yeah, some of the vibrations are the friend, and also some of the, based on the conditions which will fulfill, we can consider it the vibrations are friend and also foe. Now the friend vibrations are the conveyors, hoppers, compactors and pneumatic drills, etc. are also are friend, considering as a friend. And one more thing, some of the vibrations are useful for opening of a cork from a wine bottle, and also washing machine vibrations and machined shakers, mixers, sieves, sorters, etc. And some of the vibrations soothing, gives relaxation, the vibrations which come from musical instruments, and some of the vibrations comes from clocks and watches, and also some of the vibrations are useful for massage purposes, for medical application such as massagers, etc. Those vibrations are helpful to reduce some vibrations used for medical purposes, like massagers reduces the fat in the body. And here the musical instrument vibrations, those the strings, the vibrations comes from musical strings. Those gives the relieving. That is also one of the medical purposes. It gives stress relievers purposes, stress relieving purposes. Those instruments are used. Musical instruments, vibrations comes from musical instruments are highly useful. These are all friend vibrations, but some vibrations, always the vibrations which are suitable for our body are friend. The vibrations which causes our body for human purpose, when our body, then it is known as the foe. That is the comes under the category of foe. Here the resonance phenomenon is the foe category. That means when the natural vibrations, when external vibrations, or when the excitation force the vibrations caused by excitation force is equal to the natural frequency reaches, which are equal to the natural vibrations, then what will happen? Natural frequency, when the frequency excited by the excited force is equal to the natural frequency, then what will happen? The amplitude will be increased tremendously. That phenomenon where what will happen? Those vibrations causes highly damage to the structures. That's why the working conditions, the operating frequency should always within the limit of the natural frequency of the system. So this resonance phenomenon, what will happen? The greatest disaster, that is called Tacoma Narrow Bridge. Okay, we'll see more in further. This Tacoma Narrow Bridge, where the wind vibration causes the winds blown on the bridge, those aerodynamic forces cause the vibration frequency of those vibrations met the natural frequency of the bridge. What will happen? The bridge started oscillating very randomly, then caused the mode shapes, in violent mode shapes. Finally, the bridge collapse took place at that time in Tacoma. After the construction of the bridge, not a few years, the few years after the construction, it happened the greatest havoc in Tacoma Narrow Bridge. And one more thing, that similar problems in machine tools, vehicles, turbines, and problems, this resonance phenomena. So the four comes under when the machine works at resonance, under resonance condition, then it is 4. Now excessive vibrations, causes looseness of the parts, and eventually failure takes place. And effects of the vibration causes, when you are traveling on rough roads or hill area, you feel very uncomfort, those vibrations. That's why loss of efficiency and causes discomfort and fatigue. And finally, sound quality in products. The excessive noise in sounds. If you hear high volumes of the sounds of the cinema songs or rock metal music, this rock metal music highly damages to the eardrums. Okay, so that's why the Carnatic music is there. Hindustani or Carnatic music soothes it reduces the fatigue of the human. Our stress will be relieved by Carnatic music, whereas rock metal music causes very different excessive vibrations. It leads to fatigue and discomfort, finally reduces the lifespan of the human being. All right, now you can understand it. The vibration is a friend when it works within resonance phenomena. When it works in resonance phenomena, it is a foe condition. So vibrations are friend, both are foe also. That's why we have to choose where to be. Now there are different types of forces. Such forces are one is a static force, that is a monotonic. Another one is a dynamic force. So the static force is not divided into, is not function of time, whereas the dynamic force is the function of the time. There are 3 categories. One is periodic, another one is impulse type, and third one is random. So the periodic means is the function of time, it is a harmonic. The periodic is categorized, divided into 2 parts, that is actually harmonic, another one is non-harmonic. Okay, one is harmonic, another one is non-harmonic. So harmonic is again the steady state and a transient. Okay, in our syllabus we will study here steady state and transient conditions. Okay, now coming to the basic definitions category. What is a periodic motion? It is a function of the time and with equal interval of time. A motion that repeats itself after equal interval of time, that is known as a periodic motion. That is a periodic motion, that means it is not equal intervals of time, then it is known as, that motion is known as a periodic motion. And time period means, another definition, the time taken for one complete cycle of oscillations is known as the time period or simple period. And simple harmonic motion, the simple harmonic motion is nothing but the motion of a particle with a time that moves around a circle with uniform angular velocity. That is the first one. And trigonometric is used, that is a sin omega t or cos sin omega t and cos omega t. Sin theta and cos theta terms are to be used. This simple harmonic motion, okay, it can be circled around in uniform circle or with uniform angular velocity. Such motions are known as simple harmonic motion. This simple harmonic motion is also be mentioned. It is directly proportional to the displacement, and also it acts in opposite direction to the acceleration acts in opposite direction to the displacement. That is what here simple harmonic motion. A equal to acceleration equal to negative times omega square x. Okay, this x is the displacement and v is the acceleration. This acceleration always acts in opposite to the displacement. Here in this case, how it will act? Okay, you can explain. Is here it is. The simple pendulum is moving here in this direction. Okay, in this direction. It is the equilibrium position. When the displacement is moving, the direction of the acceleration is tendencies towards the mean position. That's what negative direction indicates. Now this amplitude, already we discussed in previous session, that is the maximum displacement of a vibrating body from its mean position. That is known as the amplitude. Next, what is the frequency? The frequency is very, very important. Operating frequency of the body is very, very important in order to reduce the catastrophe of the structure. So what is the frequency? The frequency is that the number of cycles per unit time. That is known as the frequency. What is the number of cycles per second? Cycles per second per unit time, or it is known as Hertz. Okay, this is the frequency. Now, what is the frequency? What is the frequency? F equal to 1 by T. So that's why that frequency is inversely proportional to the period of time. So time period and frequency both are inversely proportional to each other. So suppose the frequency F equal to 1 by 2 pi times and the square root of k by m, or omega n by 2 pi frequency. What is the time? T equal to 2 pi by omega n. Okay, that means the frequency and the time both are inversely proportional to each other. Next, the vibrating motion can be at either at high frequency or low frequency. At very low frequency, what will happen? Maximum amplitude takes place. At heavy high frequency, the amplitude is very small. So that's why here the vibrating motion can be either heavy high frequency can be operated very high and a very low frequencies. And also frequencies can be expressed either angular. For angular means under rotary condition, that is the angular frequency, that is known as circular frequency omega, and another one is known as the linear frequency, that is linear or oscillatory frequency, that is the F. Okay, circular frequency omega n and linear frequency, that is F is the linear. That difference, the relation between oscillating frequency and circular frequency or angular frequency, that is F equal to omega n by 2 pi. Here it is shown as circular frequency is omega. Okay, that is omega n also can be. So omega n will be used for components which are rotating, giving oscillations. Those oscillatory motions are measured in terms of the frequencies, that is omega n. That is omega n equal to under square root of k by m. What about the motions which are having number of cycles per second? The motion means which are in linear motion, oscillating. That is spring mass system. If we consider it the spring mass system or spring which oscillates, this mass will oscillate up and down. It is not in rotating. It is in linear x displacement. What about how to measure this circular? Okay, that is one is omega n by 2 pi or under 1 by 2 pi under square root of k by m. So for circular frequency, that is unit for circular frequency or angular frequency is cycles, yes, radians per second, whereas for oscillating frequency, that is cycles per second, that is or H. Okay, this is cycles per second for F. It's very, very important difference. What is the difference between oscillating frequency and angular frequency? Okay, this is the difference. That is F equal to omega n by 2 pi. Or omega n equal to 2 pi times F. That is also there. So this is all about the description of the brief description about the frequency. Now coming to the types of vibrations, there are various types of vibrations are there. Number one, free vibration. Another one is forced vibration. in broad category. And third one is also there, that is known as the damped vibration. Free, yes. Free damped, yes. No. This is a free and forced vibration. There are two broad categories. This free vibration, what will happen here? Initial displacement to the inertial element will be given, then it starts oscillating by its own elastic property. But there will be no continuous external force, doesn't exist, doesn't act on that vibratory system. But initial vibration will give initial vibration. What is that meaning? Let me explain here. Suppose there is a spring is there and it's the mass system. Okay, what will give initial displacement down? Then what will happen? It starts oscillating. This M starts oscillating from up and down. M only, this is oscillating. Initially will give, but these oscillations are taking place because of the elastic property which this elastic element, the spring, is having. But after a certain period of time, it comes to equilibrium, mean position. There will be no vibrations. Okay, those vibrations are known as free vibrations. And next, what is the forced vibration? The forced vibration means the system vibrates under external force. Okay, at the same frequency as that of external. Okay, continuously vibrating, under continuous external force. It acts, the vibrates the system. A system that vibrates under external force, continuous external force, then it is known as the forced vibrations. Those such type of oscillations are known as forced vibrations. Now there are another type of vibrations based on the axis of oscillations. That is, one is longitudinal vibration. Longitudinal vibrations. And the second one is transverse vibrations. And the third one is damped vibrations. Torsional vibrations. Torsional vibrations. Here, what is longitudinal vibrations and the transverse vibrations and the torsional vibrations? What is longitudinal vibration means? If you consider a spring mass system, or if you consider a elastic bar having a mass, it is the axis. In this direction, along the axis, if you give the vibration, then it is known as the longitudinal vibration. The transverse vibrations, it will oscillate. If it gives with some angle, then it is known as transverse vibration. That means they have some angle to the axis of the shaft. What is the torsional vibration? You give, if you see from top view, the disc. If you give rotation in the top view, the vibration oscillates in this direction like that. This is known as torsional vibrations. Now, if we give again these longitudinal vibrations, if we give initial vibration give up, then those vibrations are known as free longitudinal vibrations. You are giving continuous force. Okay, free longitudinal. If you are giving initial free, suppose you are giving initial vibration give up, it start oscillating, then it is known as free longitudinal. You are giving external force and giving vibrations, keep on giving like that, then those vibrations are known as forced longitudinal vibrations. Now coming to the transverse vibration, the transverse vibrations are, now you are giving initial some inclination give up, it start oscillating like that, but you are giving force, external force, and making to vibrate in this direction, then it is known as, those vibrations are known as forced transverse vibrations. Now again, similarly, now you gave initial angular displacement to the shaft mass and give it up. Then it starts oscillating in angular directions to and fro. positive angle and negative angle with respect to the mean angular position, then those vibrations are known as free torsional vibrations. You are giving again external force, torque, continuously, then it is known as forced torsional vibrations. So these are the various types of vibrations. Okay. Now one more thing is that another type of vibrations are known as damped vibrations. Damped vibration. Again, these damped vibrations are three types. One is again over damped vibration. Another one is critically damped vibration. Third one is under damped vibration. Okay, these damped vibrations are measured, quantified with respect to this over damped or critical damp. Under damped categories are taking place based on the damping factor. The damping factor is zeta, that is known as C by Cc. If zeta equal to 1, if zeta equal to 1, then it is known as a critically damped condition. Critically damped condition. If zeta is less than 1, then it is known as underdamped. If zeta is greater than 1, then it is known as overdamped, OD. That is UD is underdamped, CD is critically damped. So what is the C? This is the C for damping coefficient, whereas the CC for critically damping coefficient. We can relate to if C equal to CC, then it is known as critical damped. If C is less than CC, then it is known as underdamped. If C is greater than CC, then it is known as overdamped conditions. So these are the various types of damping conditions. We will see further. Now let us go for the natural frequency. This natural frequency, what is known as the natural frequency, means naturally the system is having a frequency, or then when the system is having natural frequency, means it is the frequency of a free vibration system. Free vibration of a system is known as natural frequency. And this natural frequency is a constant for a system. Remains the same, natural frequency. Okay, one more thing. This natural frequency is a inherent property of the system. One more thing. This natural frequency depends on three things. One is elastic property, another one is inertial element, that is mass, another one is a system, stiffness of the system. So this natural frequency Fn equal to 1 by 2 pi times under square root of k by m. Natural frequency of the system. Fn equal to 1 by 2 pi times under square root of k by m. What is the stiffness? This k is the stiffness. Whatever inertial element m. But this k stiffness is based on what? If stiffness is high, whatever elastic property, there is a correlation between the resolution. So here between elastic property and stiffness. This elastic property, that's why here the frequency, natural frequency depends on three things. One is elastic property, another one is mass, and third one is the stiffness. And natural frequency is the inherent property of a system. Okay. And this remains constant of the system, doesn't vary. Okay. This is natural frequency. The next important is that as we have studied the resonance under the subsection of the friend and foe. Now, when the vibrations caused by external force is equal to the natural frequency of the system, this resonance phenomena comes into the picture. What will happen here? Under that condition, the amplitude of the vibration system increases excessively. Okay, and also the system vibrates violently. During that resonance condition, with minimum input, there will be a maximum output. So hence both the displacement and the stresses in the vibrating body becomes very high. That causes damage to the structure. The next, as I mentioned, damped vibration. The damped vibration means it is a resistance to the amplitude of the oscillations or motion. Then it is known as the damping. And one more thing, it is also the sluggishness. That means it doesn't make you to move. It is inertia. When the system is vibrating because of the damping nature, yes, the positive effect of the damping is that when we are traveling on rough roads, because of the absorber shock of the spring mass system, what it will do, it minimizes the amplitude of those oscillations. That means minimizing the amplitude of the oscillations, minimizing the amplitude of the vibrations is known as a dampingness. The damping also causes what it gives comfort to the passenger. Okay. The next important is that, very important topic is that degrees of freedom. We'll study furthermore. What is the degree of freedom? Means the number of independent coordinates required to specify the complete configuration of a system is known as the degree of freedom. So this is the different topic for we'll study in the next session. But what we have covered furthermore, okay, what is the wave equation and the degree of freedom, etc. This is a different session. Now let us begin. In this session, we covered what are the basics of vibrations. Okay. What is the definition? What is the amplitude? What is natural frequency? And what are the types of vibrations? The types of vibrations such as free vibrations and forced vibrations. Again, another category based on the motion, axis of the motion of the oscillations. That is longitudinal vibrations, transverse vibrations, torsional vibrations. Again, these longitudinal, torsional and transverse can become a free and forced vibrations. And also damped vibrations also, and the types of damped vibrations, over damping, under damping and critical damping. With this, we can stop the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.